Dear student, today's topic we are discussing with you the monotonic increasing and decreasing function, and this is the class 12th level chapter, and this is important for the board exam as well as the competitive exam, and this chapter play the important roles for the cracking of IIT and other competitive exams. So this is the important chapter for you. Now at first we are giving some information about this chapter and give some laws about this chapter. After giving the law and informations, we are giving some example for this chapter. Now at first we are discussing the monotonic increasing function. In this section we can see there are two types of increasing function is there. One is the monotonic increasing functions, and this is a sequence, whereas f of a is a less and f of b is a greater, and among these f of x1 and f of x2 is equal, like these diagrams. So this is the one kind of increasing functions, and this function name is monotonic increasing functions. And now there are another types of increasing function is there, and this function is called the strictly monotonic increasing function. Why strictly? Because here f of a, f of x1, f of x2, f of b, all are in strictly increasing. No equal sign is there, like this here equal sign is there, but here not equal sign is there. This is a monotonic strictly increasing function, like this picture. So in these sections we are discussing the two types of increasing function. One is monotonic increasing function and another is strictly monotonic increasing function. This is a diagram of the strictly functions and this is the diagram of the monotonic increasing functions. Now we are discussing the monotonic decreasing function. In that sections we can see one function is monotonic decreasing and another function is strictly monotonic decreasing. In these sections we can see in monotonic decreasing functions we can see f of a is greater of f of x1 but is equal to of f of x2 and greater of f of b. That is here in these sections these two functions, that is f of x1, the value of f of x1 and the value of f of x2 is equals, but this is the decreasing gradually. So this is a diagram of monotonic decreasing, and here x1 and x2 is equals and this is the decreasing. And the next section, this is a strictly monotonic decreasing function. Here f of a is greater of f of x1, is greater of f of x2, is greater of f of p, and the diagram is this one. So starting from upper of f of a and gradually strictly is decreasing. No equal sign is there, but here is an equal sign. So in that section these two values are equals but decreasing way. Another points, there is a b and x1 y1, and here no equal sign is there, so the function is strictly decreasing. So this is the diagram of strictly monotonic decreasing function and this is the diagram of monotonic decreasing function. And now we are moved to the next sections. Now we are discussing the necessary and sufficient condition for monotonicity. Now we are dividing the necessary and sufficient condition in two parts. For the better understanding, we are dividing sufficient and necessary conditions at a time in two sides. Now the necessary condition is that fx, that is a function, given function is strictly monotonic increasing in closed interval ab. Then we can say f of x plus h is greater of fx for all a is greater than 0 and for all x belongs to closed interval ab. So in this way the next part we can say f of x plus h minus of f of x divided by h is greater than 0. Now if we introduce a limit, then we get limit h tends to 0 f of x plus h minus f of x divided by h is greater than 0. By the definition of f dash x, we can say this is the f dash x So f dash x is greater than 0. Since f dash x exists in open interval AB, so the necessary condition is this, and now we are moved to the sufficient condition. So at first we let f dash x is greater than 0. F dash x is greater than 0 for all x belongs to open interval AB, and x1 and x2 is the interior point of AB. That's the x1 and x2 belongs to open interval AB, and x1 is lesser of x2. By the given condition, we can say fx is continuous in closed interval AB, since the given condition is that f dash x is greater than 0. And similarly, by the given condition, we can say f dash x exists in open interval AB. And now by introduce the Lagrange's MVT, that is Lagrange's mean value theorems, we can say there exists an interior point C belongs to open interval x1 comma x2. Then we can write f dash C is equal to f of x2 minus f of x1 divided by x2 minus x1. Since by the given condition we see that here f dash x is greater than 0, so we can say f dash C is greater than 0, that is this part is greater than 0 we are using here. And now multiplying we get f of x2 minus f of x1 is greater than 0, that is f of x2 is greater than of f of x1 for all x1 x2 belongs to open interval AB. So this is the sufficient conditions, and now this is the necessary condition. So both the necessary and sufficient condition in a single frame for your better understanding. We are represent this necessary and sufficient condition in at a times for the sake of simplicity. Okay, we are moved to the next. Now, dear students, subscribe the channels for the more information. Now we are moving to the last part of the day, last discussion of the day of this topic, the monotonic increasing and decreasing functions. Now we are discussing one example of decreasing and increasing function at a some point. According to given informations, we can write f of x is equal to 2x square minus of 3x plus of 1. F dash x is equal to 4x minus of 3. At the point f dash 0 is equal to 4 into 0 minus of 3. This is the 0 minus 3. This is the minus of 3. 0 minus 3. This is the minus of 3 lesser 0. So by the conditions we can say fx is decreasing since f dash 0 less than 0. And now by putting of x is equal to 1, and then we get f dash 1 is equal to, putting here the value of x, 4 into 1 minus of 3. So this is the 4 minus 3, and now this is a 1 greater than 0. So f of x, that is a given function, is increasing at x is equal to 1. Hope the given information and the example will help you to understand this chapter. In future, when you practicing this chapter, this video will help you to understand this chapter better.